talk a lot of different important things. You are not in class, sorry. Okay, just joking. Where am I? So solid state. So in solid state physics, it is essentially this kind of couple oscillation system. And today I'm going to talk about n equal to 2. N equal to 2 means there are 2 masses and 3 springs. That's the easiest way to couple 2 masses together. And then I will extend to n equal to 3. And then if you are familiar with n equal to 3, it's so easy to extend to n equal to any number. Okay? So therefore, our calculation and the language, the mathematical language we use could be easily generalized to any kind of solid. In jargon, it is called one-dimensional monatomic chain, or monatomic chain. Okay, just like this. It's in chapter 9, so it's almost a starting point of solid state physics. In solid state physics, you have to be able to describe how the solid state look like and how the atoms inside the solid states oscillates. Again, the key word of our first course, or the first half of our semester. Therefore, again, this formalism is essential to your understanding of solid state physics. And if you are going to TSMC, you are intended to go to TSMC, solid states is almost the first step in that direction. Okay, after solid state, then maybe semiconductor, and then maybe some other company, and later TSMC. So this is in your future. This is in your future. So I'm not talking about very obsolete physical question of couple oscillation. It's essentially what you are going to learn in the future. Okay, and crucial to your career. Remember this, okay? 好，所以呢，这个很重要啊，哈。Okay, and then after, before the semester, maybe I probably can only finish up to this point because we have so many to cover. But a natural extension of the formalism up to this point, matrix eigenvalue problem, is to take the continuous limit. This in Chinese, continuous limit. Okay. What the continuous limit means, you can take the limit so that the separation between 2 atoms are so small, it feels like a continuous medium. Continuous medium. In Chinese, 你把这个2个原子之间的这个距离呢，把它趋近无限小了以后 when you take a equal to 0, and then you get a continuous limit. OK， 你就变成是一个那个连续的介质 ，continuous medium， continuous medium，medium not medium，continuous medium， 就变成是一个连续的介质。OK， that's essentially solid, right? OK, when you talk about a solid or a conductor, you don't talk about the atoms inside. You talk about one piece of solid, one piece of metal, one piece of conductor. So you have to take this limit to be able to describe a real world material. Okay, so when you take this limit, continuous limit, taking a equal to 0, then you get a partial differential equation. And partial differential, the typical example of partial differential equation is wave function. It's wave function. That's supposedly is the keyword of the second semester. Maybe that will be the keyword of the keyword of our second semester, the first part. OK， 所以呢，来 let me put it in Chinese。那你把这个刚刚讲的这样子一个 couple mass 的系统，把它取了一个连续的极限了以后，所谓连续的极限就是你把这些原子跟原子之间的距离，把它趋近于很小很小很小很小，那你不会变成是连续的东西嘛 ？OK， 好，但这么讲是这样讲 ，mathematically how to do it, you have to be very very careful to taking this limit, but it's doable. So after you take this limit, then it becomes a continuous medium, 连续的介质。在一个连续的介质上面，你就会发现你的这个 eigenvalue problem becomes a partial differential equation. And the partial differential equation, the typical one,典型的就是波方程式。OK， 好，我们可能来不及在这个学期介绍到波方程式，但是下学期 definitely 是我们最重要的一个概念啊。波方程式，电磁波，然后呢，这个薛定谔方程式，还有古典的其他的弦波的波方程式。You will see that all these wave functions are identical in how to solve them。啊，解这些波方程式的方法竟然是完全一样的，好，竟然是完全一样的。That's the essence of the whole course, our whole course. Okay. Any question? So before I get into, and then, so couple oscillation, you can also consult the lecture notes of Professor Schwartz. Lecture 3 is a couple oscillation, and you can, if your eye can see clearly in the fourth lecture from oscillators to wave. Yeah, exactly. So I'm more or less following the logic in this lecture notes. Okay, so couple system, couple oscillation, spring mass system, whatever you call it, that's it. Okay, we have two masses, M1 and M2, and they are coupled by three springs, K1, K2, and K3. And K1 is fixed on the left-hand side, K3 is fixed on the right-hand side, and K2 connect the two. So that's why we call it couple, because this K2 couple the oscillation of this M1 and M2. So if there is no K2, there are two separate oscillators. However, because you put the K2 in between, this oscillation and this oscillation couple with each other. Do you see the point? Okay. Yeah, so this is called couple oscillation. Let's write down the equation of motion. And because there are two particles, there are two equations of motion. Let's do the first. X1 is the displacement of M1. Of course, I assume that at x1 equal to 0, x2 equal to 0, the system is in equilibrium. But that's okay, right? 就是一开始的时候，我是把它放在平衡点上面。So x1 will tell you the force exerted by the left-hand side spring, which is minus K1 x1 from the left-hand side. However, there is a right-hand side spring exerting another spring force on M1, which is determined by the change of length of K2, the second spring. And the change of the length of K2 is x2 minus x1. Is that okay? Because originally, it's the natural length. This move x2, this move x1. Then x2 minus x1 is the change of length. Okay, it will, according to Hooke's law, it will determine the force exerted by this spring on both sides. Okay, this spring will exert forces on M1 and M2. Later, when I write down the equation of motion for x2, you will see the same kind of force exerted by the second spring. So first, this is the x1. So the equation of motion will be written as m1 dx1 dt squared is equal to k2 x2 minus x1. x2 minus 1, the force exerted by second spring, minus k1 x1, that's the force exerted by the first spring. Remember, to this direction is positive. Okay, so if x1 is positive, then the force is negative because it's a restoring force. Okay, so this is this negative sign is crucial. You don't forget this negative sign. Okay, so then okay, so that's the equation of motion for x1. And we usually, on the right-hand side is the force exerted on x1, on mass 1. And we usually want to collect all the terms related to x1 and x2 separately. So I will, x1, write it first. It will be minus k1 plus k2 times x1 plus k2 x2. Is that okay? very simple manipulation, and it is easier this way. And any question? Okay, raise your hand. Okay, I will try to go slow, very slow, so that you can understand almost all of my lecture. Because if you don't understand any piece of information on the screen, then you probably accumulate. you misunderstood a little bit, it becomes very quickly. You don't remember what I'm talking about in class. Of course, you can go back home and see the picture, the movie. However, it's better to learn it in class, right? But otherwise, why don't you stay home and put your own air conditioning, right? Okay, so that's the x1 equation of motion, and the x2 will be described by a very similar equation of motion. So we will not go into detail, but you can do it on your own. And so at dx2 over dt squared, that's the acceleration of the mass 2, is equal to minus k2 x2 minus x1. That's exactly the same force compared. So it's exactly the same. Sorry, here. So this and this. Okay. So it's exactly the same force exerted by the second spring on M2. Remember, this M2, this K2 exerted the same spring force on both sides. Okay, Hooke's law. So this minus K2, x2 minus x1, but here for M2, this direction is positive, so this is a negative sign. And then K3 will exert the force on M2, so it's minus x3, x2, x2. Yeah, I think it's right. Okay, so then I again collect all the terms related to x1 and related to x2 separately, and then you got the equation of motion. 4. So a typical situation in couples oscillation, you have two equations of motion, two ordinary differential equations. Okay, and usually they are coupled. When I say coupled, that means x1, the equation of x1 will involve x2. Of course, it's here. And for equation of x2, it will involve x1. They are coupled. They are not oscillating separately. They are not. But you can see, if I cut off the K2, then K2 equal to 0. Then this term disappear, and this term disappear. When they disappear, x1 are only related to x1. x2 are only related to x2, which we usually say it is decoupled. Okay, so for example, United States wants to decouple from China, something like that. They don't want to trade with each other. They don't want to have anything with each other. Decouple it. Okay. If I cut K2, then x1 do its own way. x2 do its own way. They are not related to each other. However, if I put a K2 in, then they are coupled. So that's why it's called coupled oscillation. So when you solve equation for x1, you have to remember x2 is also involved. When you solve equation for x2, you have to remember x1 is also involved. So they have to be solved together. That's the point. That's the point. You have to solve them together. Okay, so and then on the right-hand side, the force are actually the force of the exerted on M1 and M2, and they are linear to x1 and x2. Linear in x1 and x2. Usually, this force, we will say that this force is a linear combination of x1 and x2. Linear combination, again, a constant times the function plus constant times the function. So constant times the function plus constant times the function. So linear combination. So force are linear combinations of x1 and x2. It's usually called linear system. Linear system. 线性系统. Okay. Almost all physical systems in nature are linear system. So what you learn from this very, very simple and maybe unrealistic example actually could be applied to almost all branches of physics because nature are linear. Natures are linear. 很奇怪 ，for no reason， 大部分的物理系统都是线性系统。OK， 所以呢，你在这个课堂上面学到的东西，在大部分的物理的系统里面都会 work。比如说电路系统啊，自然界的振动啊、地震啊 ，almost everything are linear system. Okay, so remember what you learned are not solely related to just this very, very unrealistic system, but actually is related to almost all physical system in nature. Okay. So now, usually we like to move all the constant to the right-hand side. So M1 to the right-hand side, M2 to the right-hand side, we'll get this two equation. That will be the starting point of our discussion. Okay, after half an hour, we finally start. We finally start. The mathematical question, the mathematical problem, how to solve these two ODE system or system of ODE. Okay, how to solve them? For simplicity, let's first assume that the two springs are the same. The three springs are the same. I think K3s are also the same. Sorry. So let's assume that K1, K2, K3 are all the same. Okay, and M1, M2 are the same. Therefore, I call all the same K as K, all the same masses as M. Therefore, this equation could be simplified into this form. Of course, you can restore, and later I'm going to restore to the most general case and do some calculation and do some discussion. However, so that we can concentrate on the simplest case. So let's concentrate on this most simplest differential equation. Okay, so K1 plus K2 equal to 2K. K2 is equal to K, and K2 is equal to K. K2 plus K3 is equal to 2K. So that's the stuff. Okay, and to make it even simple, and of course it's a system of second order linear ODE. No problem. Oh, sorry, I missed one line. And in order to make the formulate the notation even simpler, I'm going to assume that K over M is equal to omega 0 squared. Sorry, originally I have this formula here, so I write it down here. So I assume omega 0 squared is equal to square root of K over M. Okay, Okay, so this will be omega 0 squared. This will be 2 omega 0 squared. So in the next, I have already do it in the new notation. So I'll put this line back here. Okay. So of course you have to remember this omega 0 squared, square root of K over M, is the angular frequency of one oscillation system, right? If you compare to what we learned in the first half of the semester, we usually call it omega. But here, because we are going to solve the angular frequency of the system, it could be different from K square root of K over M. Therefore, I give it a new notation called omega 0 squared. Okay, but originally it's omega. 这个符号叫做 omega 0平方但是它就是原来我们在讲一个线性系统、一个简谐运动系统的时候的那个 omega。Remember？ 对，这个是这样才对。Sorry， Remember， 在一个简谐运动的时候，我们 omega 设的是根号的 k 除以 m。这就是 the natural frequency of a spring system。但是现在我给它一个 zero，because 这个符号我们等一下会有用。这个 omega 等一下会有用。We are going to solve the angular frequency omega for the whole system. It's different from square root of k over m. So 在这里我先给它一个新的 notation， 叫做 omega 0平方。Is that okay with everybody? If so, let's do it. Method 0. Okay. Method 0 means a very intuitive and very guessing style of solving problem. Later, I'm going to give you method 1 and method 2 and method 3. Actually, in this problem, very excitingly, we have 4 different kinds of methods to solve it. As according to Feynman, if you cannot solve a problem in 3 different ways, you don't understand the problem. Okay, so that's why I'm going to tell you 4 different kinds of ways to solve this question. And all of them are very, very interesting and very, very important. Okay, so let's start with the simplest one, the most intuitive one, method 0. Method 0. Of course, because these are second-order differential equations, these are second-order equations, why couldn't we just use the complex number method to it? 我们为什么不就用刚刚才学会的复数的方法，放到它上面就好了 ？If you think so, that's so. Okay. So the method 0 is complex number method. I will just use the same kind of language I use. So first, I elevate all the real x into complex function. Okay, but I don't want to write z again. So then the equation will become too complicated. So I will retain the notation x1 and x2. But you have put in your mind that these x1 and x2 now are complex number. But in the end of the day, I'll take the real part. Is that okay with everybody? So first, elevate the x into complex function. And I guess the solution is a complex number exponential function, just like in our exam or in our discussion for the last couple of weeks. So I will assume that x1 is equal to a1 exponential I omega t, x2 equal to a2, another constant, times exponential I omega t. Is that okay with everybody? It's a guess. Of course, the most natural way to guess is to write alpha, the complex number, instead of I omega. You see the difference? I should have write e to the alpha 1t, e to the alpha 2t. Oh, sorry, alpha 1t, a1, a2. Okay. Alpha, the complex number. But I'm going to show you that they are imaginary. But in a couple of weeks, after we do the linear algebra. Okay, after we do the linear algebra. Okay, so I'm going to show you that alpha 1 and alpha 2, alpha 1, all the solution of alpha 1, all the solution of alpha are imaginary. Okay, be patient. Take about 2-3 weeks. I'm going to show you for all the natural problem in nature, for all the natural problem in physics, alpha are imaginary. Okay, but that's good because if alpha is imaginary, I can write it as I omega. Then if I omega is oscillating. Remember the opening remarks I gave you today. If the alpha is imaginary, that means the system is oscillating. Cosine omega t plus 1, right? So if I write it this way, that means this system is oscillating. Of course, this is a spring-mass system. Except for oscillating, what can they do? What else could they do? So of course they are oscillating. Do you understand? So 你本来就是一个弹簧的系统它当然就 oscillating 了。OK， 你又没有放任何的阻力在里头它就是一直震荡，一直震荡，一直震荡，怎么震，怎么解是我们等一下要做的事情。But of course they are oscillating, so that's why I can assume that the alpha is imaginary, and therefore I can write directly x1 equal to a1 exponential I omega t, x2 a2 exponential I omega t. This is first step. If you don't understand the first step, I'm not sure how I'm going to go further. So any question? 可以吗 but anyway, it's a guess. If it doesn't work, it doesn't work. So let's see if it works. 让我们来看看它到底行不行嘛？总之，这是一个很好的猜想 这是很好的一个猜想，所以是一个 method zero， 就它本身就是一个猜想，能不能够用，就要等到我们做了以后才知道。好 ，method zero。And actually, there are another very important characteristic of this guess. That is, for example, I originally write this alpha 1, alpha 2. But here, I only write omega, only one omega for both particles. Do you see that? This is the essence of this guessing. 哦，这个才是整个的这个猜想的最重要的核心，那就是 all the omega are the same. Both, not all, both omega are the same. So in Chinese, in English, in this guess, x1 and x2 oscillate with time in identical manner with the same angular frequency, omega. I didn't write omega 1, omega 2. I write omega. Do you see that? So that means the two particles are oscillating together. I will show you the motion picture later, but that's my guess. So A1 e to the I omega t, A2 e to the I omega t. Let's see if it works. To see if it works, I just plug it into the equation of motion. Okay, so as usual, every derivative gives you an omega squared, right? So x1 to the second derivative of it will be equal to omega squared e to the I omega t A1. Is that okay with everybody? Because we take two derivatives of second order, so it will be omega squared. It should be minus omega squared, of course, but we will cancel out the negative sign on the right-hand side. So it will be omega squared times x1. x1 is a1 exponential I omega t. The second term, I just need to plug in. The third term, I only just need to plug in without doing any differentiation. So this is A1 times the whole thing, A2 times the whole thing, and omega 2. And the second equation, when you plug in x2 into the second equation of motion, again, omega squared exponential I omega t A2 equal to the same kind of expression on the right-hand side. Simply plug in x1 and x2 without any differentiation. It's messy on blackboard, but you do it at home slowly with a cup of tea and with air conditioning and maybe some music. You will see that it's not that difficult. Okay, so you see this very complicated expression, but it's not so complicated as you see in your eye, because exponential function can be cancelled out. It appears everywhere. Well, that's the essence of the guess, because all the differentiation of an exponential function are exponential function, so it appears everywhere. So you can cancel it out. After you cancel it out, what did you do? You cancel out an exponential function of time, and the rest are time independent. Do you see the point? 你把时间全部消掉了 ，What is left? 跟时间一点关系都没有。Ladies and gentlemen, so we got a function, equation of function. We transform it into an equation of numbers with this guess. Okay, with this guess. We transform an equation of function of time into an equation of numbers. Oh, in jargon, it's an algebraic equation. Differential equation is transformed into an algebraic equation. That's not new. That's exactly what happened in the first half of the semester, isn't it right? 第一个学期我们就是一开始就是把 differential equation 一直把它变成了代数方程式嘛。We did it again. We did it again. In the first half of semester, we transform an ODE into an algebraic equation. Now we transform a system of ODE into a system of algebraic equation of A1 and A2. Ladies and gentlemen, that's what we have here. Okay. Oh, sorry. I forgot this line. And this omega, you may ask, what is omega? Remember, omega 0 is definite. It's a known number, a parameter, a constant, whatever you call it. But this omega is a constant, but we don't know what it is. Okay? we don't know what it is. So it's a real unknown number to be solved. We will solve it. Okay, it's not anything. In the next couple of transparency, we'll show you that this omega could be solved. Okay. Any question? We'll have a break in about 10 minutes, so be patient. 很快. Wow, this is not difficult mathematics, but it's exciting and very sophisticated, I would have to say. Now, we have two ODE. we have two algebraic equation, or we call it system of algebraic equation of A1 and A2. Let me list it here. Usually, again, we like to move all the terms to the left-hand side because, after all, the right-hand side it consists of A1. There is an A1 on the left-hand side. So better to combine them together into this term, this constant times A1 minus this constant times A2 equal to 0. The second half equation, the same. I will move the right-hand side to the left-hand side. You will see this equation. Okay, so these are all algebraic equation for A1 and A2. Omega are also unknown, but let's pretend that we know what omega is. So these are equations for two unknown, A1 and A2. Oh, so this is actually system of algebraic equation in a homogeneous form. Homogeneous means there's nothing on the right-hand side, right? Okay, so of course, you know one solution. A1, A2 equal to 0. Everything vanishes. If A1 is 0, A2 is 0, of course their combination is 0. A1 is 0, A2 is 0, of course their combination is again 0. So without doing anything, if it is a homogeneous equation, we immediately know there is at least one solution. A1, A2, or both equal to 0. But that's not what we want. We don't want a solution that, remember, A1, A2 are the amplitude of x1 and x2. So if A1 and A2 are both 0, then they don't move at all. Yeah, of course that's a solution, because if we put the two masses at the equilibrium position in the beginning, they will move, of course. But that's not the solution we want, right? We want them to move and to oscillate. So, in order for this to have a non-zero solution, the only possibility is that the determinant is equal to 0. This is the famous Cramer's rule. Cramer's rule. I think 大部分学生都知道 Cramer's rule, right? So, do you understand this? If it has a non-zero solution only if the determinant is equal to 0. 这个方程式如果把这个看成系数，这个看成系数，这个看成系数，这个看成系数，那么这个方程式呢要有不为零的解，唯一的可能是你的行列式是等于0。知道吧？你不知道吗？不，你知不知道？好像有 ，OK， 好嘛，好，高中有教嘛，对不对？好的，记得，把它记起来 ，memorize it. No. You can go to Afghan. Of course, not everyone is familiar with high school mathematics in Taiwan, so you can go to Afghan, the page 83 to 85 and 88. Actually, that's the beginning of chapter 2. Okay, the beginning of this Afghan textbook. Okay, and so you can see this Cramer's rule. But actually, you don't need a Cramer's rule. You just need to know this statement. Okay, if you want this equation to have non-zero solution, the only possibility is that the determinant is equal to 0. Everyone needs to know this. Okay, everyone needs to know this. Otherwise, we won't be able to proceed. almost every question in the final exam will be about this kind of eigenvalue problem solving. OK， 好，所以期末考的考试，所有的题目都会跟这个东西有关系。好，所以 as a homework or whatever, try to convince yourself this statement. This statement. We don't really need a Cramer's rule, but we need this statement. This equation has non-zero solution only if the determinant is equal to 0. Is that okay?
那你是怎么直接定义那一串的 omega 平方 a1， 然后下面又等于 omega
哪里？
上面
对，这个。
就是你是怎么定义？
定义什么东西？
omega。
来。So you're asking a very important question. Omega 0, yeah, I miss.
定义了 omega 0等于 f 平方等于 f。
对。
但是。
Yeah, 所以 that's why he's asking why I define omega 0 equal to k over n, because here is k over n.
怎么定义 omega？
Oh, omega. Omega is here.
定义 omega。
Yeah, that's a good question. Don't confuse omega 0 and omega. Omega 0 is a constant we know. Omega 0是一个常数我知道的 k 除以 m， 那就是我刚刚讲的，就是弹簧系统的自然的频率，其实就是我们原来的 omega。我们在上节课的时候所讲的那个 omega。But this omega is a guess. I guess the solution could be written in this way: a1 e to the I omega t. But we don't know what omega is. Omega 还没有解啊。It's a very, very good question. So that's why I have this. It should appear earlier. Omega is a real unknown to be solved. So that means in this guessing, we have three things unknown. A1, I don't know. A2, I don't know. Omega, I don't know. But it's exactly the same thing as here, right? But it's not new. But in your complex, when you do the complex number method, you assume the solution. 在你的那个期中考啊，你好像还写对啊。你不是就假设它是 A1 e to the alpha t 吗 ？A2 那这个 A1 你也不知道啊，alpha 你也是不知道啊。So plug in your guessing to the equation of motion and solve alpha first, and then you find that A1 你可以调整。You compare this guessing to what you have already did, it becomes very clear. This omega is actually alpha. 你当初也是不知道 alpha 是什么啊 ？Okay, yeah. Okay, so I hope it's all clear. So at least at this moment, omega you don't know what it is. Alpha 1 you don't know what it is. A2 you don't know what it is. Just like in the original complex number method, you don't know A1, you don't know alpha. The same thing. But we're going to solve them. Do as best as we could to solve them. Okay. In the original method, you get the algebraic equation for alpha. 在原来的问题里头，你得到了一个 alpha 的代数方程式，把它解出来嘛，不是吗？对啊，你有解对啊。哦，所以那个时候你把这个 alpha 解出来。So let's see if we can solve omega. Let's see if we can solve omega. Of course, I already almost solved it. Because if you accept this statement, this thing has a non-zero solution only if the determinant is equal to 0. In Chinese, 这个东西会有解，只有当你的行列式等于0的时候。因为如果不等于0的话，你的这个解永远是0啊。OK， 好，永远是0啊。所以呢，行列式是0，那条件就是这一个行列式必须要等于0，这不就是一个 omega 应该满足的条件吗 ？So this is the condition omega, the unknown, unspecified omega has to satisfy, almost like the algebraic, the second order equation, alpha has to satisfy. 我们不是在解题目的时候把它带进去里头，你不是写出来一个阿尔法平方什么减掉加上3阿尔法，不懂4阿尔法加上3等于0嘛 ，right？ 你解了阿尔法的时候 is 1 and 3， minus 1 and minus 3。Here is the same. You got an equation, a condition omega. Of course, it's in different form because it's system of ODE. That's just one ODE, but it's just essentially it's quite the same thing. Here again, if we demand the determinant to be equal to 0, then you got a condition for omega. Omega. I can solve it right away for you because this the determinant 行列式的定义 is this times this minus this times this, right? So that is omega squared minus 2 omega squared. Squared because you multiply the two identical elements together and minus again the identical together element together omega 0 squared. Could be solved. It could be solved so easily. Omega could only be omega 0 squared and 3 omega 0 squared. Done. So the unknown now is known. The unknown is now known. Omega could only be omega 0 or the square root of 3 times omega 0. Otherwise, you don't have solution. So you got two solutions for omega. So that means I will have two solutions for x1, x2. Two solutions. That's good. Remember, in ODE, the original ODE, we got two solutions, cosine omega t and sine omega t. Here, I also have two solutions for omega equal to omega 0 or equal to square root of 3 omega 0. So for system of oscillation, the frequency could be different. But still, we have two solutions, this and this. Is that clear to everybody? 好，所以呢 yeah, so the unknown omega square only have two options. Either it is equal to omega 0 or it is equal to square root of 3 omega 0. Okay, so when the now with omega solved, I can go ahead to solve A1 and A2. It turns out A1 and A2 has some freedom, but their ratio has to be the same. And mathematically, it is because when the determinant is equal to 0, the system of equation, the determinant is equal to 0. These two equations, we call it, are linearly independent. 线性相关. Okay, they are in not. This is jargon. So in ordinary language, when they are linearly dependent, that means they are essentially the same, since the one can be written as a multiple of the other. OK， 其中一个方程式，事实上就跟另外一个方程式一样的。你不相信 ？Let's see. So now let's proceed to solve A1 and A2 for omega 1 equal to omega 0. Okay. The second part will be solving A1 and A2 for square root of 3 omega 0. Give me 3 more minutes. I can solve A1 and A2 for you, so that you have a much better picture of what I'm going to do it. So now omega, the first solution is omega 0. Just the same as we expect. So let's call it omega 1, so that we have two on frequency. So we have two notation to separate omega 0 and square root of omega 0. So if omega is equal to omega 1 equal to omega 0, so I should have omega equal to omega 1. Then if I put it back into the equation, the two equation, then this is omega square. If you put omega 0 back into it, then it becomes 2 omega 0 squared minus omega 0 squared times A1 minus omega 0 squared A2. This is essentially this one. Okay, and you put the solution 1 into it. Okay, let me put it in Chinese. 这个就是刚刚的这个方程式，好，刚刚的这个线性方程式。那我把这个 omega square 刚刚已经解出来2个解，所以把其中的一个解呢，把它放进去，我来看看你的 A1 跟 A2 会是多少。OK， 因为我刚刚已经解出 omega 来了，那我们还想知道 A1 跟 A2 是怎么样啊？好 ，if I put it in, then it becomes omega 0 square A1 minus omega 0 square A2 equal to 0. The second one, after simplification, it is minus omega 0 A1 plus omega 0 A2 equal to 0. So omega 0 is a non-zero number, so it can be cancelled out. So the first equation becomes A1 minus A2 equal to 0. How about the second? The second one, minus A1 plus A2 equal to 0. Of course, they are the same. Or better, the second equation is minus the first one. So that's why I say if the determinant is equal to 0, then the second, they are the same because one of them could be written as a multiple of the other. 所以当你的这个行列式等于0的时候，其实你并不是有2个方程式，其中一个事实上是另外一个的 multiple， 就像这里 ，one of the equation, the second one is actually the first one times minus 1. Okay, yeah. So actually you have only one solution. Okay, if you have one solution, you cannot solve it all. But you determine the ratio between A1 and A2. 它们俩之间的比例你就知道了。So that's the basic structure of an eigenvalue problem. Eigenvalue problem. A1 and A2, you cannot determine it completely, but you can determine the ratio between them. So here in this case, A1 equal to A2. That means A1 over A2 is equal to 1, according to the first equation. And the second equation are the same as the first one, because the determinant is equal to 0. So let's call it, because they are the same, let's call it C1, so that we have another constant. And this constant is complex, so that I can write it as A1 exponential I phi 1. The amplitude of the absolute value, the argument. And then if you put it back into x1 and x2, x1 is A1 times exponential I omega t, so it becomes C1 exponential I1 omega t. Okay? And C1 is this. So then you can combine the argument with I omega t to arrive at A1 exponential I omega 0 t plus phi 1. Identical x2, the same story. x2 is A2 times exponential I omega t, but A2 is C1 again. Therefore, it equal to C1 exponential I omega t, and you can write it as A1 exponential I omega 0 t plus phi 1. So we solve everything we can solve. Okay, so take the real part. Remember, when I say take the real part, you know that we are at the end of our argument, right? So take the real part. The real part of this thing is A1 cosine omega 0 t plus phi 1. So x1 oscillating. What about x2? x2 is also oscillating in exactly the same way. So because x2 is equal to x1, exactly the same equation, exactly the same expression, okay? And that's the result of A1 minus A2 equal to 0. Because of this, so A1 equal to A2. So because A1 equal to A2, remember our original assumption, A1 is the amplitude of x1, A2 is the amplitude of x2. So if A1 is equal to A2, of course the x1 is equal to x2. It's so simple. It's so simple. Okay. So maybe it's a bit weird on blackboard. So when you get home, try to take a look at the whole picture, and you will see that it is a very, very simple argument. Okay, but the physical significance is great. So x1 equal to x2, so they oscillate together. So they oscillate together, and with the same omega 0. Okay, so if you put in the motion picture, you will see this x1 and x2 move together like this. Move together like this. Okay, so this kind of mode, we call it, because it becomes an oscillation. Whenever you see oscillation, we call it a mode, or we call it a mode, because it looks exactly like simple harmonic motion. Remember this word. If you find anything that looks like a simple harmonic motion, of course this is simple harmonic motion, then it is a mode. 模式，它就是一个模式。And this mode is very elegant because it's has a very simple characteristic. 有一个非常非常简单的特征 ，because the two move together, so we call it symmetric. OK， 叫做对称模式，对称模式。When you come back, let me show you a picture for you. We got some very good website that will offer you. Let me how to do it. Oh yeah. There you go. I did not tune the starting point exactly right, but that's give you some idea. I will come back to the same motion picture later, but that's what the symmetric mode means. Okay, so you can see x1 and x2 are the same, so the same oscillating function. And from the left-hand side, you see that they move together. They move together. Okay. So this is the symmetric mode, symmetric mode. You might ask, if there is a symmetric mode, is there an anti-symmetric mode? That means they move opposite to each other. If you are thinking about that, you are right. Because when we come back in 5 minutes or 10 minutes, I will show you another solution, square root of 3 omega 0. If you do the same thing with it, you will see that actually A1 and A2, A1 plus A2 is equal to 0. Okay, that means x1, x2 is equal to minus x1. Okay, and you will see that they move anti-symmetrically. Okay, let's have a 10 minutes break.
11点报告。再说，如果我还醒的话，老师。不让我出。应该中间吧。他们这个次序是错乱。不知道。不，好 ，OK。